Right, hello, welcome back to another video. Today we're going to be continuing on with our blueprints exploration. I'm going to be having a look at using splines within blueprints. So again, construction script, making up little tools to help artists build our scenes. And we're doing that with splines. So firstly, I just want to have a look at the spline mesh actor. If I can type it, spline mesh actor. So this is a way of creating kind of like deformity from a static mesh. So if I just load in a simple cube, what we'll see is we get two handles. So effectively what we have here is a skeletal mesh with two bones, and it's automatically rigged those two bones for us and gives us sort of the ability to create a simple curved shape. Let's try something with a bit more geometry. Let's try the chair, quite like the chair. And so we can create weird, deformed, stretchy things. But it can be really useful for pipes and cables, anything like that, where you might want to have something that's a little bit dynamic and a lot of variety in the curvature. You don't want us to import lots of different static meshes, and so you can use a spline mesh to do that. One thing you can also do here, we can adjust the axis that it's bending along, and so we can create a kind of slightly weird bent curved chair there, and it's really useful. And we can also add some twist, things like that. So I can add start roll, this kind of thing. Very powerful kind of type of actor that we can use. It's more expensive than just using a static mesh because it's become a skeletal mesh basically. It uses a different rendering pipeline, but definitely worth using where you need those kind of cables and that kind of thing, pipe work. Cool. So we're going to be using that within Blueprint with a blueprint spline. So if we just create a new blueprint actor, PP spline, and up here in the components, I'm going to add a spline, and we can see spline mesh. That's what we just looked at, but we can also see spline, and this is unique to blueprints. And what this is very similar in that it's a few points defining a kind of curve. But what's different about a spline in blueprints is we can alt-click and drag to sort of duplicate, and we can add multiple spline points, and we can create kind of like a defined curve. And this is very powerful. So in this case, I'm just editing what's inside the actual default of my blueprint. Obviously I can adjust the tangents and the points, but we can also make this editable. So if I just delete that one and add a new one to get it back to the default, if I bring a copy of this into the world, go back out of game mode, we can see it's also editable here. If I can select the right points, so you can build your splines or your curves up in the engine, in the viewport, and have them different and dynamic for different sort of settings. Really cool, really powerful. This can be a path, so you can animate along a spline. This can be used to sort of create something like a fence, where you want to just draw out a lot of points dynamically in the engine, or again, kind of cables, chains, anything like that, where you might want to have lots of hanging points. So at the moment it's just a spline, it doesn't render. If we go into game mode, we can't see anything, and so we need to create some meshes that fit along our spline. And there's two ways to do this. One is just to do one mesh per segment, so the gaps between points are called segments, and we can do, in this case it would be 3, and you'll get a little bit of stretching with your mesh, so you might need to kind of adjust your points, and we'll do that way first and sort of see how that works. So if we get our spline and we get a reference to it, we can do a loop. So we can get a number of spline segments, get a number of spline points. That's just going to dynamically count how long our spline is. Obviously, if we dynamically make it longer, more points, we need to have more meshes. So in this case, I'm just going to do it based on the number of segments. Let's try that. And we want to do a for loop. Not for each, we're not dealing with an array. We just want to do a for loop based on the number of segments. And in this case, if I just have a look, to remember our counting. So we've got 3 segments. So we want to loop from 0, 1, and 2. So we want to do a number of segments -1. So I'm going to subtract 1 from here, and that will be our last index. So this will say create a loop, number of spline segments -1. Let's go around counting 0, 1, 2, and that's going to give us our 3 segments. Now what do we want to do in that loop body? Well, we want to add a spline mesh component. That's what we just looked at. In this case it's a component, so it's part of the blueprint rather than a spline mesh actor, which is just living in the world. But we want to add a spline mesh component, and I'm just going to do a set static mesh here, and then we can create whatever mesh we want to use, and I'm just going to promote that to a variable, and now make that instance editable, and we'll be able to just update whatever mesh we want in our blueprint at runtime, or at editor time, I guess. And I'm going to call this spline mesh. Let's recompile that. Okay, so we've added our spline meshes. We need to tell it where to sort of start and stop. In this case, it's not following the spline at all. I'll move this around. See, it's not connected in any way. And we can do that with another blueprint node called set start and end. Very simple. So it's fine to put it over here. So we need to get the start and end positions and the start and end tangents, and we can do that. So we can do it based on our spline. So again, I'm going to bring another reference into our spline, and if I pull off a pin here, we can get position. Is it not position? It's location, isn't it? Get location and tangent at spline points. So we're doing this based on the number of points, and we're doing it so we're going to have one mesh kind of at each point, or one mesh between each points. So if this one is the first index, so the first time round we want the first point, and we're just going to use the index from our loop as our point index. So this is going to be index 0, and we want the location, that's going to be our start position, and we want the tangent, it's going to be our start tangent. And then we also need to get the same information for the next point. Oops, wrong way around. So if we're making a mesh that goes between these 2 points, the start's at 0, the next one's at 1, and so that's just going to be this index plus 1, and that's going to be that kind of next point. So same node here, get location and tangent at start point of this spline at this point. And if I do a start and end here, click compile, hopefully we've got our mesh stretching between those 2 points. So if I grab this point and move it around, we're getting that sort of stretching happening. If I adjust the tangent, it's going to bend. Nice. If I add another one, we're going to get a second chair. Now, obviously a chain of chairs isn't that useful, but you can go out and make your own mesh, pipe or chain or whatever it is. You might have to do something with the join. If it was pipe work, you might want to add some non-deforming meshes at each join to kind of hide that. But I'll leave that up to you to experiment with different meshes. Pretty cool. One thing I would like to do here is maybe set my forward vector or forward axis. So we saw before with the chairs, these are probably alright, but we might want to kind of adjust this to be forward axis Z, something like that. And we want to maybe expose that as well. And that's simply enough. So we just do set forward axis. And I'm just going to do a bit of cleanup, try and arrange this in such a way it sort of reads well, makes sense. So, and then we can promote this to a variable as well. Forward axis. Okay. So what's happening here? Getting the number of segments in the spline. Obviously that's going to be dynamically adjusted as the spline gets longer, looping over that number of segments, and then just adding a spline mesh for each one using point 0 or point index and then point index plus 1, and that's just going to count through until we get our spline. Just check it here in the viewport. This is all working correctly. Really nice. Strange set of chairs, but there we are. That's the thing. It is what it is. Obviously we can adjust this. Let's try arrows. Oh, they're really big. We could adjust the scale. We haven't exposed that parameter, but there is a set start and end scale. Let's just do that then as well. So forward axis, start and end, set scale, set start scale, set end scale. And the last one, set end scale. Scale. And you can see you can do the roll and all that kind of stuff as well. So depending on the asset you're making and how much you need to do that. And I might just make this a float. Oops, not called float. Mesh scale. Edit all exposed and float. And if I drag this in, it should. No, it's not going to do it. Fine. If I split these, there we go. That's what I want to do. So I just want to enforce a uniform scaling for what I'm doing now. And I'll just set that to 1 as a default. And now hopefully, if I've done all that correctly, I have a mesh scale and I can scale these up and down as I need, which is pretty cool. So that's one way of doing a set of meshes along a spline. You can see here we've got some stretching. These ones are longer than those ones. And that's fine, depending on the way we've made our mesh. If we had sort of a uniform texture, if this was a rope, that might start looking a bit bad. We're going to have kind of, what's the word? You're going to have some stretching, some long ones, some short ones. If I go in here, have I got anything that's got maybe a bit more geometry? Maybe we should have prepared a piece of geometry that had more, piece of mesh that had more geometry. We'll just go back to the chair. So you could default. It's got enough geometry to bend around corners and things. So obviously when you're bending your mesh, it only bends when there are vertices. So putting in a cube, you're going to get a very straight thing like we saw before. Anyway, we'll worry about the mesh later. So now that we've got this, these ones are very stretched. Well, there's maybe a different way we can do the whole thing, and that will be based on a number. So if we say rather than having one mesh per segment, if I say I want exactly 7 meshes, 1, 2, 3, 4, 5, 6, 7, and then we use equally spaced points along the spline. So we can do that instead. So I'm just going to leave all this up here, and we're going to make an option for this later, and we're just going to start again completely from scratch. Be neat and tidy, and do sort of the other method based on a specific number. So in this case, I'm going to start with a variable, and I'm going to call this number of meshes, and this is going to be an integer, because a number can't be a floating point. We can't have a half a mesh. I'm going to do something very similar. So we're going to do a for loop. Now, if we're going to have 3 meshes, then we want to count from 0 to the number -1. So we do our subtract 1 again here. So 3 meshes would loop 3 times here, starting to count at 0. And then we're going to do the same, or very similar setup. So add static, what's it called? Add spline mesh component. We want to do a set mesh. That's spline component, it's not spline mesh. Add spline mesh component. There we go, that makes more sense. And then set mesh. And we're going to set it to be the same thing as we used before. Oops. Put that one in. And then also set start and end. Now in this case, we're not using the spline points, but we're going to use a distance along the spline. So if I bring in the reference to the spline, up here we used get location and tangent and spline point. Well, there's another node, get location at distance along the spline. And we need to work out what that distance is. So the way we do that is we take our spline, get the length. So this would be dynamically how long it is. And then we want to divide that length by the number of segments, which will be number of meshes minus 1. Is that right? Just divided by the number of meshes, that's right. Make sure I'm doing my maths correctly. And in this case that will convert automatically. So now we know how long each segment is. So if our spline is length 90 and we've got 3 meshes, or 3 segments, 3 meshes that we're trying to put in there, each one's going to be a length of 30, and then we can just multiply this by our index, and that's going to control our counting. So we want integer times float. So how does that work now? So we know how long each of the segments is. The first time around we don't want any length because we want the initial point, so we multiply by the index multiplied by 0, and then this distance can now be what we get for our distance along the spline, and we put that into our start position. Same principle again. If we do the just trying to arrange this sort of neatly, if we do the index plus 1, that will be the next sort of point along, or the next segment along, and we can do this multiplied by our distance, or our segment length, and we can get the location at that distance of this spline. Just kind of give this a bit more room to breathe, make it a bit clearer to see what's going on, and that will be our end position. So if I just compile this and have a look, in this case my number of meshes is defaulted to 0, well that's not much good, but now if I add more and more meshes, you can see hopefully all the meshes are the same length, because we're sort of segmenting our spline down by the number of meshes and then using that sort of distance and length to create our placement based on that loop. So yes, number of meshes, -1 to make the loop, get the sort of segment length, and then we do, let's do it this way, print that out, either the first index or the index plus 1 multiplied by that segment length, and we can do our start and end locations. Notice we haven't used the tangent yet. Well, in this case the get location and tangent at spline point does both for us simultaneously. In this case we just have to use a second node. So we've got location, we can also get tangent, and get tangent at distance along spline. Not sure why they're not together, but they aren't. But that's not a real problem. We can do this and get our tangent and distance like so. And I might just swap them around for the sake of neatness. So the top two, these lines aren't crossing anymore. If I compile that, now we're going to get our chairs following that curve based on the tangent as well. Pretty cool. Couple more things, almost done with this. I've got the 2 options in my construction script. All I'm going to do is have a branch and then create a variable that allows me to switch between the 2 methods. Swap methods and make that editable. And so if it's true, use this one. If it's false, use this one. Maybe I should name that something a bit more descriptive about what it's actually doing. So if this is, I don't know, use mesh count, something like that. And now it's the wrong way around. Here we go. Use mesh count, true uses the bottom part, doesn't, uses the segment length. And we can have the option now to swap between the 2. And so this will now be based purely on the position of the points, and this is now based on the number of segments, which is really, really useful. So one last thing I want to do is let's make a copy of this, shall we? Yeah. I'm going to do a quick animation using that spline. So rather than using anything in the construction script, I'm just going to delete, or not delete, but just unhook all of that. So this blueprint's now not doing anything. And in the event graph, I'm going to create a timeline. So we looked at timelines last week, or last lesson. Spline anim. And all we need to do is animate using that distance along spline method. So if I get my spline and get the length, there we are. I'm going to do a get location at distance along spline. I guess use the same reference to that. And I'm going to do the length multiplied by a value that I animate from 0 to 1. So 2 keyframes, 1 at the full length of time, 1 at the start, and it's just going to follow along that spline. And this is in a sort of normalized 0 to 1, and then the spline length is going to give us that distance multiplied together. So at time 0, 0 is going to be 0, 0 times anything. At time 1, it's going to be the full distance, and that's going to give us the full distance along here. And we can make this loop here in the timeline. And one of the things we haven't looked at is in a spline, we also have an option here for a closed loop. If we tick that on, it's going to draw, always going to draw a last segment to go back to the end. And so you can create this kind of figure of 8, whatever shape you want to do. So what am I going to do? Well, I'm going to take a static mesh. Obviously this can be whatever we like. Let's use our chair again because it's a good debug object. And all I'm going to do is just set the position and the tangent at that distance dynamically over time. So we've got location at distance, get tangent at distance along spline. Distance is from here. And I'm going to do a set location. Now we have to think a little bit about spaces. So there we've got the option of where the coordinate space, which coordinate space we're getting. So the distances and tangents we're getting are in local space. So you want to set this as relative location and rotation. So it's local to the blueprint and then relative to the parent, which in this case is the seam root. So that should be correct. So set this on update, static mesh, new location will be location. And now we've got a tangent here, but this is looking for a rotation, but luckily Unreal's pretty good. If we just plug that straight in, it's going to work out that we need a rotation from X vector node in between, and that should set this up correctly. So if I simulate this now, it's following our spline, and we're animating our chair along that path. So we've got a nice dynamic animation path that we can build into our scene, and we can put whatever we like along here and set whatever controls we need. Cool. So a couple of things, or 3 major things here. Either animating with the timeline, and that's going to follow that around. Ooh. Oh, that's because my spline isn't set. Interesting. BP time. Oh, that's the timeline one, not the spline anim. There we go. Didn't use the chair as the debug object every time. We can animate directly via timeline. We can also animate with a spline and timeline. There we are. Little revision from last time. There we go. So we can animate along a spline, and we can also go in and set a number of meshes or a specific number of segments. That's not updating because we're in play mode or simulate. There we go. So a number of meshes specifically, which we can obviously go in and set whatever we like, or a number of meshes based on segments. Cool. Hope that was helpful. As always, big thanks to my Patreon supporters. If you do have any questions or comments or anything, let me know, and I'll see you all next time.